Hello students. So today we will discuss the tangents and normals to a general conic. The equation of a general conic. So to find the equation of a tangent at the point to the conic ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Suppose we are given the equation of a general conic and suppose we are given a point on this conic and we have to find the equation of the tangent to this conic at that given point. So what is the tangent to a conic? Suppose this is the conic and this is the point P where we have to find the tangent. Then what is the tangent? Suppose we have a neighboring point Q on this conic. If you join P and Q, we have the chord PQ. Alright, so this chord will become the tangent to this conic if at the point P this chord will become the tangent to this conic at the point P if this Q comes closer to P and coincides with P. So as Q comes closer to P, so if Q also comes here, then this line will become this line. The line PQ will become this line, the tangent line, if Q comes closer to P and coincides on P. So what is tangent to a conic at a point? The tangent to a conic at a point is the limiting position of the chord PQ, where Q is a neighboring point to the point P. So the limiting point of the chord PQ as Q approaches P is the tangent to this conic at the point P. So this is how we will find the equation of the tangent at a given point to this conic. So let the given point be, so equation of the conic is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, and suppose the given point is x and y1 and we have to find tangent at to this conic at the point P, at the point x and y1. Alright, so let P be this point x and y1 and Q be a neighboring point. Let Q x2 y2 on the conic. So we have to find the tangent to this conic at the point P x and y1 on this conic. This point lies on the conic. Let the point x2 Q x2 y2 be a neighboring point at the conic. Okay, suppose Q is another point on the conic. So since these 2 points are on the conic, so though these points should satisfy the equation of the conic, so this implies ax square plus 2h x y plus by1 square plus 2gx1 plus 2 y1 plus c equal to 0, and the other point also should satisfy the equation of the conic ax2 square plus 2h x2 y2 plus by2 square plus 2g x2 plus 2f y2 plus c equal to 0. Now what is the equation of the line PQ? Equation of the chord PQ this equation of the chord PQ would be y minus y1 is equal to slope of this chord. The slope of this chord would be y2 minus y1 over x2 minus x1 into x minus x1. This is the equation of this chord, the chord PQ. Alright. So from these two equations, let's write this equation as alright. So from these two equations, we will try to find out this y2 minus y1 over x2 minus x1. So what we do is we subtract the first equation from the second equation. From this equation, we subtract this equation. So we get a into x2 square minus x1 square plus 2h x2 y2 minus x1 y1 plus b y2 square minus y2 square plus 2g x2 minus x1 plus 2f y2 minus y1 and c minus c is 0. So we subtract first equation from the second equation. Now this part, now we use an identity. Now we use the identity that 2 x2 y2 minus x1 y2. This can be written as x2 minus x1 into y1 plus y2 plus or minus y2 minus y1 into x1 plus x2. Right? So we will use this identity. This is an identity with us. We can use this identity. This is plus sign here. Alright. 2 x2 y2 minus x1 y1 is equal to x2 minus x1 into y1 plus y2 plus y2 minus y1 into x1 plus x2. This you can see this works out well. So this x2 y2 minus x1 y1 can be replaced by this. So this equation becomes a, this factorizing this x2 minus x1 into x1 plus x2 plus h x2 minus x1 y1 plus y2 plus y2 minus y1 x1 plus x2 plus b y2 minus y1 into y1 plus y2 plus 2g x2 minus x1 plus 2f y2 minus y1 is equal to 0. So what we do is we take, first of all, we take x2 minus x1 common. So what remains is a x1 plus x2 plus h y1 plus y2 and plus 2g, and plus we take now y2 minus y1 as common. So what remains is, if you take y2 minus y1 as common, you take h x1 plus x2 plus b y1 plus y2 plus 2f equal to 0. Alright. So from this equation we can write, that y2 minus y1 over x2 minus x1 is equal to minus a x1 plus x2 and this so y2 minus y1 over x2 minus x1 is equal to this. This is what we wanted to find here in the equation of the chord PQ. So equation of the chord PQ becomes, equation of chord PQ now becomes y minus y1 is equal to this y2 minus y1 over x2 minus x1, whose value is here. So this is equal to minus a x1 plus x2 plus h y1 plus y2 plus 2g divided by h x1 plus x2 plus b y1 plus y2 plus 2f into x minus x1. X minus x1 here. X minus x1. So this chord PQ will become tangent at P if Q coincides with P. And Q coincides with P means x2 approaches x1 and y2 approaches y1. So let x2 approach x1 and y2 approach y1. That means let Q approach PQ. So when Q approach PQ, this chord becomes the tangent at P. So in this equation, let x2 become x1 and y2 become y1. So this equation becomes y minus y1 is equal to. So this implies the equation of the tangent at P x1 y1 is y minus y1 is equal to, as x2 becomes x1 and y2 becomes y1, this is equal to minus 2a x1 plus 2h y1 plus 2g divided by 2h x1 plus 2b y1 plus 2f and x minus x1. So this becomes the equation of the tangent at the point P, because the chord PQ becomes the tangent at the point P if Q approaches to P. So equation of the tangent is this. From here you can cancel out 2 everywhere. So this equation can be written as ax1, this 2 will cancel everywhere. So this is equal to ax1 plus hy1 plus g into x minus x1 plus hx1 plus by1 plus f into y minus y1 is equal to 0. So this is the equation of the tangent at the point P, and this equation can be rewritten as this equation can be rewritten as is equal plus this can be written to the other side. All right. So this equation can further be written as ax1 is equal to ax1 square plus 2h x1 y1 from here plus by1 square plus gx1 plus fy1. So what we do is we add gx1 fy1 plus c here, and also subtract gx1 plus fy1 plus c both sides. Gx1 plus fy1 plus c both sides. We have added this into the both side to balance it. But this plus this becomes 2gx1 plus 2f1 plus c. So the right hand side is ax1 square plus 2hx1 y1 plus by1 square plus 2gx1 plus 2fy1 plus c. But this is 0 because the point x and y1 lies on this conic. Since the point x and y1 lies on this conic, so this is 0. So this you put as 0. So equation of the tangent becomes ax1 plus x plus y so this is the equation of the tangent to this conic at the point x1 y1. This is how it is done, and this equation can also be written as axx1 plus hxy1 plus yx1 plus byy1 plus gx plus x1 plus fy plus y1 plus c equal to 0. This equation can also be written like this. This can be written like this, and both of them are equations of tangent to this conic at the point x1 y1. If this part on the left hand side, or this part on the left hand side, we call as t. So this equation of the tangent can be written as t equal to 0. Equation of the tangent can be written as t equal to 0, where t is this part on the left hand side, or this part on the left hand side. And how to write this part? You replace x square by xx1, replace y square by y1, replace xy by 2xy by xy1 plus yx1, and replace 2x by x plus x1, and replace 2y by y plus y1 in this equation. In this equation, if you replace x square by xx1, replace y square by y1, replace 2xy by xy1 plus yx1, and replace 2x by x plus x1, and replace 2y by y plus y1, then we will get this equation, and this equation is the equation of the tangent to this conic at the point x1 y1. And this equation in short can be written as t equal to 0, where t, how can you find t? Where t is replace x square by xx1, replace y square by y1, replace 2xy by this, and replace 2xy this, and replace 2y by this in this equation. There is another way to remember the equation of the tangent, and that is how to remember this equation. This equation of tangent can also be written like this. And how to write this equation? This equation is, what you do is you remember this determinant AXG, HBF and GFC. This, you remember this determinant was called delta. This determinant can be called delta. So this is AXG, HBF, GFC. So the first row is AXG, second row is HBF, and third row is GFC. So how you write the equation of the tangent? Write AHG, AX1 plus HY1 plus G. This is AHG into X, plus second row HBF, HX1 plus BY1 plus F into Y. This is second row into Y, plus GFC. This is the third row, GX1 plus FY1 plus C equal to 0. This is the third row. So using the first row, you can write AX1 plus HY1 plus G. Using the second row, you can write HX1 plus BF, HX1 plus BY1 plus F. and using the third row you can write gx1 plus fy1 plus c. So this is also how you can write the equation of the tangent to this conic at the point x and y. Alright, and this is a better way to write the equation of the tangent. So I hope you have understood how to write the equation of the tangent, and now we will see how to write the equation of the normal. That is pretty easy. So next we find the equation of the normal to the conic at a given point. So equation of the normal, what is the normal? Suppose this is a conic with us, and suppose we have a point P here, x1, y1. Let's call the equation of the conic as s equal to 0. This equation conic can also be written as s equal to 0, where s is this part. Because this part is s, then the equation of the conic can be written as s equal to 0. So what is the tangent at the point? Suppose x and y1 is a point of the conic. What is the tangent? The tangent is a line which touches this conic at only one point. This is the equation of the tangent. And what is normal at the point P? A normal at a point P is a line which is perpendicular to the tangent and passing through the point P. This is called normal. This line is the tangent to the conic, and the line which is perpendicular to the tangent and passing through the point P is called normal to the conic at the point P. So the equation of normal to the conic, this let's call this conic as s equal to 0 at the point x and y1. So to write the equation of the normal, first of all we write the equation of the tangent. The equation of the tangent at P x and y1 is P equal to 0. Is P equal to 0. That implies we will use the first three rows A, H, G, H, B, F. We will use the three rows of this determinant. The determinant we call as delta. We use the three rows of this determinant to write the tangent. So A, H, G. First row is A, H, G. So ax1 plus hy1 plus g into x plus second row is hbf, hx1 plus by1 fy plus third row is gfc, gx1 plus fy1 plus c gfc is equal to 0. This is the equation of the tangent to the conic at the point x and y1. What is the slope of this tangent? The slope of this tangent is equal to minus coefficient of x divided by coefficient of y. So what is the equation of, what is the slope of the normal? Slope of the normal. If the slope of the tangent is this, normal is perpendicular to the tangent. So the slope of the normal would be hy1 plus hx1 plus by1 f divided by ax1 plus hy1 plus g. Because the product of the slope should be minus 1. This multiplied by this should be equal to minus 1. So that is why the equation of the normal is this. So slope of the normal is this. So what is the equation of the normal? This implies the equation of the normal is y minus y1. The normal passes through the point x and y1. So y minus y1 into slope. Slope is this hx1 hbf plus ahg into x minus x1. So this is the equation of the normal to this conic at the point x and y1. The equation of the normal to this conic at the point x and y1 is given by this. So this is how you can find the equation of the tangent and the equation of the normal. So next what we do is we have to find the equation of a pair of tangents from a point x and y1 to a given conic ax square plus 2hxy plus by square plus 2gx plus 2ly plus c equal to 0. Suppose we are given a conic, this conic, whose equation is given like this, and suppose we are given the we are given a point P whose coordinates are x and y1, and from this point suppose we draw two tangents to this conic. Then what is the joint equation of these two tangents? That we have to do. We have to find. So suppose we are given the equation of a conic, and suppose we are given a point P x and y1, and suppose from this point we have to draw two tangents to this conic. What would be the joint equation of these two tangents? We will see that the joint equation of these two tangents is given by ss1 is equal to t square. ss1 is equal to t square, where what is s? Where s is ax square plus 2hxy plus by square plus 2gx plus 2y plus c, left part of this equation, where s is this, where what is s1? Where s1 is, put x equal to x1 and y equal to y1 in this expression. So ax1 square plus 2hxy1 y1, 2hx1 y1 plus by1 square plus 2gx1 plus 2y1 plus c. This is s1. And where what is t? Where t is the as we write in the equation of the tangent. So in the equation, to write the equation of the tangent, you replace x square by xx1, replace y square by y1, replace 2xy by xy1 plus yx1, replace 2xy x plus x1, replace 2y by y plus y1. So that is t. So if s is this, s1 is this, and t is this, then ss1 is equal to t squared gives you the equation of the joint equation of these two tangents. How do we do that? Any line that passes through the point x and y1, its equation is this. The equation of any line that passes through the point x and y1 is given by x minus x1 over L is equal to y1 is y1 over m is equal to r, where any point on this line which is at a distance of r from the point x and y1, its coordinates are given by this. x1 plus lr and y1 plus mr are the coordinates of any point on this line whose distance from the point x and y1 is equal to r. So if this point lies on this conic, then this point should satisfy the equation of the conic. This point should satisfy the equation of the conic. So we get this equation, and this equation, if we write in terms of a quadratic equation in R, this equation can be written like this. So we get a quadratic equation in R, and if this straight line, the line passing through x and y1, has to be a tangent to this conic, if this line has to be the tangent to this conic, then the two roots of this, if the line cuts, then the two roots of this quadratic equation would be different. But if this line is the tangent to the conic, then the two roots of this quadratic equation in R, the two roots of this quadratic equation in R would be equal if this line if this line has to be the tangent to this conic. So if this line has to be the tangent to this conic, then the two roots of this quadratic equation should be equal, and that means discriminant should be 0. So you put the discriminant of this quadratic equation equal to 0, that gives you this. Okay, this part we can call as S1. This portion we call as S1. So put the discriminant equal to 0, and now replace L by, from here you can write L is equal to x minus x1 over r and m is equal to y minus y1 over r. So if you replace L by x minus x1 over r and m equal to y minus y1 over r, then replacing the value of L and m in this equation becomes this equation. Alright, this equation becomes this equation, and this part it can be easily seen that this part is actually t minus s1 and this part is s plus s1 minus t. This part is s plus s1 minus t multiplied by s1. So this whole equation is actually t minus s1 equal to s plus s1 minus t multiplied by s1. Where what is s? Where s is this, s1 is this, t is this. So if you square of this t minus s1 square, t minus s1 square. So t minus s1 square is equal to s plus s1 minus t into s1. So if you square this and open this bracket, what remains is t square plus s1 square minus 2s1 ts1. So here you have ss1 plus s1 square minus ts1. So things cancel out and what remains is ss1 is equal to t square. Alright, from here you will write ss1 is equal to t square. So we have got the equation of the pair of tangents from this point to this point. The joint equation of this pair of tangents is given by ss1 is equal to t square. This is how we find the joint equation of pair of tangents. I hope this is clear to you. Now we have another short article that suppose we are given the equation of a conic s equal to 0 and suppose we have a chord in this conic and suppose px and y1 is the midpoint of this chord and suppose px and y1 is the midpoint of this chord of this conic. What would be the equation of this conic? What would be the equation of this conic whose midpoint is given? So that also can be done using this article. Any line that passes through the point x and y1, any line that passes through the point x and y1, its equation is this. And any point of this equation on this line, its coordinates would be this. Any point on this line at a distance r from x and y1, at a distance r from x and y1 would be this. So if this point lies on the conic, then it should satisfy the equation of the conic, and that means we get this quadratic equation in R. Now, since this point is the midpoint of this chord, so the two roots of this quadratic equation in R, would be equal in magnitude but opposite in sign. If one root is R, other root would be minus R, because this point is on this side of the point, this point is on this side on the left, and this point is at equal distance on the right, because this point is in the midpoint of this chord. So the two roots of this quadratic equation would be equal but opposite in sign. That means sum of the roots would be 0. So if the sum of the roots of this quadratic equation is 0, then the coefficient of R must be 0. Alright? Since the sum of the roots of this quadratic equation is 0, so the sum of the roots must be 0. So if sum of the roots is 0, then you have got this. Now again replace L by x minus x1 over R and replace m by y minus y1 over R from this equation. So if you replace L by x minus x1 over R and m by y minus y1 over R, you get this equation, and this part we have already seen here. This part we have already seen here. This part is t minus s1. So you get t minus s1 equal to 0, and t minus s1 equal to 0 means t is equal to s1. So t is equal to s1 is the equation of this chord whose midpoint is x and y1. T equal to s1 is the equation of this chord whose midpoint is x and y1. So this way we can write the equation of a chord whose midpoint is given as t equal to s1, and the equation of the joint equation of a pair of tangents from a given point x and y1 is given by ss1 is equal to t squared, where s is this, s1 is this, and t is this. Is this clear? Thank you, and we'll continue with more topics. Thank you.